on question number 3, I understand that the bases are the same for the two, but like just for clear understanding, so I understand the Bronson Lowry base is any ion like except
any substance doesn't have to be an ion that can accept a hydrogen ion.
And so in the Lewis base, it's gives that it offers an electron pair. So that means like when the hydrogen ion comes, it offers the hydrogen to like bond with us.
When from a Bronsted-Lowry point of view, a base is something that will accept a hydrogen ion. Well, guess what it is about the base that allows it to accept a hydrogen ion, an unshared pair of electrons.
Okay.
So every Lewis base is a Bronsted-Lowry base. Every Bronsted-Lowry base is a Lewis base. The big difference between Bronsted-Lowry acid-base theory and Lewis acid-base theory is the acids.
Can you go over number 7A? Because if it's spontaneous.
You need to have your acid-base chart out, right? So if you're given an acid-base reaction, such as you are in number 7, in order to determine whether it's spontaneous or not, you need to look at the bases that are competing. What are the two bases competing in 7A? SO3 minus 2, that's called the sulfide ion. Your ion chart is a good resource for you in this chapter as well. And the acetate ion, CH3COO minus, the conjugate base of acetic acid. Okay? Now, which of those bases is stronger? In the acetate ion, we find the sulfite ion. Which is stronger? Sulfide is a stronger base? Yes? So which one is doing the taking? The sulfide. And it's the stronger base. That's going to happen, huh? Right? Let's look at B. What are the two bases competing? Now, look at the two reactants. Isn't each an acid? Isn't each a base? So how can you tell which one is acting as the acid and which one is acting as the base if they're both acids and they're both bases? Oh, yes, the one that has gained hydrogen on the product side, huh? Which one has gained a hydrogen? The HS minus has gained a hydrogen, and the H2PO4 minus has lost a hydrogen, huh? So the H2PO4 is acting as an acid, and the HS minus is acting as a base. You can't tell by which one is listed first on the reactant side, right?
Yeah.
So when both things can act as an acid and both things can act as a base, then you need to look at the right-hand side to see which one they're actually doing. We okay? Zach, I believe your thing is right there. Permit to leave, sorry. Okay? So what are the two bases that are competing? HS minus, which is called the hydrogen sulfide ion, also called the bisulfide ion, and HPO4 minus 2, huh? Those are the two bases that are competing. So we look on our handy-dandy list of bases. I find HS minus, and right underneath it is HPO4 minus 2, which means HPO4 minus 2 is the stronger base, huh? Yeah? And the stronger base is starting out with the hydrogen ion, and the weaker base is trying to take it away, right? Now that will happen some of the time, but not very many of the times. Yeah? So we say this reaction would not be spontaneous. And then C. Once again, we have two things that can act as both an acid and a base. You will find both of these things listed on both sides of the arrow on your acid-base chart, won't you? Okay? So we have to look at the products to tell which one is acting as a base and which one is acting as an acid. Who's acting as a base? The NH3. Notice that we don't always list the acid first and the base second. In this case, the NH3 is the base, acting as a base, and the HCO3 minus is acting as an acid. Now, there's lots of students when we're doing this that listen to what I say and then ignore it and develop their own kind of technique for doing this. Strongly recommend. Done this for a long time. I found that the best way to approach Bronsted-Lowry acid-base reactions, which is spontaneous, is to talk in terms or think in terms of the bases that are competing. Right? Okay? So, the bases that are competing are NH3 and CO3 negative 2. Okay? And which is the stronger base? Now, careful. You're going to look on the right-hand side of the arrow, right? You're not going to find NH3 on the left-hand side, because there it is at the bottom, huh? Ooh, must be the strongest. There it is at the bottom. But at the bottom, it's acting as an acid, isn't it? Get it? So we find ammonia. Where is it? There it is, acting as a base. And we find CO3 minus right underneath it, huh? So the I said CO3 minus 2. CO3 minus 2 is the stronger base. And who's starting out with the hydrogen ion? The stronger base, huh? So that won't be spontaneous either. Getting it? Okay. What's next? Let's say that. Number 11 was, I assigned that because it was my hope that you would try to look up the answer in the book, because we haven't talked about it yet. And if you did that and made sense of it, great. If you did that and made no sense of it, that's okay too. Okay? If you didn't look in the book and didn't try to answer the question, then you're behind those people who did. Right? Because they're ready to talk about this.
Can you just read the answers for number 4 and 5?
So the strongest acid is the oxalic acid. Is that right? Let me double check. Yep. The oxalic acid is written oddly in the table. It's written as HOOCCOOH. The reason they write it like that is it looks like this. That's oxalic acid. Most of the times people write it as HC2O4. H2C2O4, thank you. Okay. So, the oxalic acid is the stronger of the two. Moving to the right as acids now, HS minus and HPO4 minus 2. As acids, HS minus is the one closer to the bottom, so it's HPO4 minus 2 is the stronger acid. And then underneath those, the carbonate ion, CO3 minus 2, is the stronger base, and the sulfide ion, S minus 2, is the stronger base. And of course, number 6 ties those two questions together, doesn't it? Isn't the strongest, isn't each of the ions in number 5 the conjugate base of the acid directly above it? Did you notice that? If you didn't, do you now? Okay. And wouldn't we expect the conjugate base of the weakest acid to be the strongest base? Right?
Do number 9, please.
So fluoride and sulfate. Those are our two bases that are going to be competing. Who's the stronger base? Who's the stronger base? Fluoride is the stronger base. Okay, you all there? Sulfate is the weaker base. So if we're going